and really looking forward to this fascinating discussion. Thank you.
Thanks for the introduction, Sue. I hope everyone can hear me okay. I know that probably the words "the new normal" have been used over and over again, but I imagine the team at CogX has been working 24/7 to make sure that this happens nonetheless. So thank you to the wider team at CogX. To introduce myself, my name is Nick. As Sue mentioned, I'm one of the founding partners of the Aviary project. We are a community platform and an advisory firm for the UAM or urban air mobility industry. I have a bit of a varied background in innovation consultancy and UAV engineering, but more recently, we've started looking at some of the economics and potential applications of urban air technologies, as well as the services and how they're actually going to end up being rolled out for passenger transport. Before we get to the speakers, I want to give a little bit of context to what we're talking about today. Aerial mobility technologies are being developed all around the world, but it's really important for us to understand why we're building this industry and these technologies right now. I mean, for one thing, we're seeing unprecedented population sizes in urban areas, and there's a limit to the capabilities and the capacity of existing ground-based infrastructure. So using the skies and expanding into the third dimension really starts to make a lot of sense when you think about that element of it. But really, why now? I mean, helicopters have been around for a long time and have already got the ability to take off vertically and land vertically and to transport people around cities. There even have been in the past large-scale aerial mobility operations in New York, London, and a range of other places around the world. But a lot of these were really just doomed to failure. I mean, in part, this is because helicopters are incredibly noisy, and they're actually quite unsafe in certain respects compared to other forms of aviation. But for me, one of the major barriers about this area of aviation is just the sheer cost of helicopter transportation. For one thing, helicopters are incredibly complex machines and as a result are really expensive to maintain. I mean, a great example of this is that you have to change the oil every 25 flight hours or so. I mean, imagine having to do that with your car. It just wouldn't really, it would add up and make it incredibly infeasible for a lot of people. Recently, however, there have been some really impressive developments in the field of electric aviation technologies, which have made vertical takeoff and landing vehicles, aka VTOLs, much simpler, safer, and cheaper to operate. You can see some of the best and most varied examples of this in multi-rotor photography drones that have been around for the last decade or so. And these have been advancing rapidly over the last few years. But the industry isn't just about creating new vehicles. The aerial mobility industry is about creating a new paradigm, an ecosystem of technologies that will encompass everything from autonomy to reduce the need for pilots, unmanned traffic management to increase the capacity of our skies, new infrastructure to support ground operations, and much, much more. So with the first speech today, I'd like to introduce Dr. Anita Sengupta, who's going to be talking a little bit about that ecosystem. Dr. Sengupta is an aerospace engineer, educator, instrument-rated pilot, rocket scientist, and a veteran of the American space program. She has developed technologies that have enabled the exploration of Mars and deep space for more than 20 years, but she's now currently a research professor of astronautics at the University of Southern California. She's focusing now on green transport, space propulsion technology, but is also an aviation entrepreneur. She's one of the founders of Hydroplane, co-founder of ASX, which is building an eVTOL, and on the board of NCTAR, looking at supersonic aircraft without the sonic boom. Ladies and gentlemen, please welcome Dr. Sengupta.
Thank you so much for the introduction, Nick, and hopefully everyone can hear me all right. So I'm going to talk a little bit broader today about sort of the future of flight and bring some of my space program background to discussion to make it more interesting during the Q&A session. But as Nick described, I am an aerospace engineer by training. I did spend the majority of my career working for NASA, specifically on electric propulsion, but for deep space applications. And I decided to bring my space program training to the transportation sector about 2.5 years ago. I worked on developing a Hyperloop transportation system at a startup, and now I have more than one company in the electric aviation space. And so to talk about aviation at a high level, it does actually lend itself to a problem, which also lends itself to a solution, which is the carbon footprint of aviation. And the aviation sector, although in a little bit of a holding pattern right now because of COVID-19, is a very much rapidly growing sector, which means an increase in CO2 emissions, which means an increase in the potential for new technologies to facilitate reducing the carbon footprint of that sector. And what is interesting is because of the change and shift in technologies for ground-based transportation, by 2050, we actually see aviation as being a prime contributor to CO2 output. So we really do need innovation now to meet climate directives that are coming about around the world. When we talk about aviation, we talk about, in one sense, general and business aviation, which is where I personally fly as a pilot, both on the general aviation side in smaller aircraft and on smaller jets on the business aviation front, under what's called Part 135 operations in the United States. What most of us fly, of course, is commercial aviation, and that is currently in a holding pattern, pun intended, because of restrictions of travel across countries because of the global pandemic. And we all don't really enjoy commercial aviation because it can be sometimes be very crowded, it can be expensive, and there's a concern, of course, associated with COVID-19. And I recently was back up in the air last weekend, and this is the new normal for us pilots in the cockpit, where we do have to wear masks so we don't transmit the virus between us. And that probably will persist for another 6 to 12 months is my guess, depending upon how things go on that front. But when we take a look at the carbon footprint of the aviation sector relative to other sectors, right now it is quite small, but once those other sectors do fully shift over to electric vehicle drivetrains, then aviation will be the primary contributor of CO2. And then we look at it from a individual passenger transit perspective, domestic flights do have the largest amount of CO2 emissions as well as secondary effects due to flying at high altitude because of those CO2 emissions. So we can really see that we do need to make a change on this front to reduce the carbon output of aviation. And we look specifically in the context of the European Union, you can see that how over time other sectors have reduced their CO2 emissions, whereas aviation is very much on the rise, largely due to the commercial aviation sector as opposed to business and general aviation. So what is the future and what could the future look like for air mobility? Well, first, one of the things I did for many years in my career in the space program is work as a systems engineer. And so one of the ways that you can create an entirely new architecture is to think about it from a systems engineering perspective. And so when we think about transportation from a systems engineering perspective, we have to think about our customers, and our customers are largely the traveling public or the flying public. And the goal for any transport system is to reduce your travel time, to have a good passenger experience, to meet the capacity needs of your use case, to be safer than the prior form of transit that you were using, and to be cost effective. And as I just sort of discussed, the environmental impact is key. And scalability and interoperability are also key in implementing any changes to the aviation and aerial mobility sector. And so I am an engineer. I'm a huge science fiction fan, and I actually go to science fiction for a lot of my inspiration. And in this graphic here, you can see flying cars that were envisioned in the 1960s in the American cartoon The Jetsons, about a modern family. And I think urban air mobility really has taken off as a result of thinking about those different ways of moving around. And when you think about it in the context of urban environments, congested and distributed cities, such as where I live in Los Angeles, traffic does literally control your life, which means it has an impact to your quality of life. It also has an impact to the bottom line in terms of wastage of fuel, wastage of time, and the inability of goods and services to move around at a pretty rapid pace. So when you look at the economic potential of that sector, you can really see that the urban air mobility sector, which also includes suburban travel to rural travel, has the ability to give you a global addressable market of over $1 trillion by 2040. So it's also a ripe business opportunity in terms of investment, and we've seen a lot of that, and we'll have more discussion on that today. But when we think about congestion, if you can go away from the 2 dimensions of ground-based traffic, as Nick said, and go to the 3 dimensions of airspace, you really can alleviate that congestion. Now, one thing which is really wonderful about the urban air mobility use case is that it's inherently short range, which means that it can therefore shift over to being fully electric and emission-free. The other aspect of the urban air mobility use case is that you want to be able to land in congested areas, which necessitates the ability to take off and land vertically. So there are many companies in the space. I'm co-founder of one. This shows you the graphic of the tilt wing aircraft that we're working on. And what we're doing here is giving you an update to a similar platform, which would be a fixed wing aircraft, but has the ability to tilt its wing and take off and land vertically. With the reduction in range, we're able to be fully battery powered, which then would give you the emission-free configuration. And the other nice thing about this from an ecosystem perspective is that there are ways to leverage existing hardware and software from the automotive sector, which has shifted over to being EVs, and put that into the aviation sector. Another part of our discussion today will be related to infrastructure. So urban air mobility is not commonplace right now, which means that there aren't a lot of heliports or landing pads in urban centers, which would need to be built, but not to despair, because we do have a great deal of existing infrastructure from the general aviation space, which could be used. You can see here in my example, in the vicinity of Chicago, there are many airports which are currently underutilized and can be used for that suburban, urban, and rural aerial mobility set of use cases with infrastructure that exists today, as new infrastructure is built over the course of the next 5 to 10 to 15 years. In terms of the use cases, there are many. One of them, of course, is cargo and critical goods. When you think about developing a new aircraft platform, you can have an aircraft flying for one type of use case, which would be cargo and critical goods, before it actually shifts over to the passenger carrying use case. Another really important one, where I live, which is in Southern California, is emergency response. So we have fires here all the time. The ability of having a platform which is more environmentally friendly, more cost effective, that has inherent to it a short range mission profile, eVTOL, and electric aircraft in general can support the emergency response. Similar to that, medical evacuation use case, always the domain of helicopters, incredibly expensive in terms of a per hour cost. Shifting over to an eVTOL platform reduces that cost, which means more aircraft are available to this use case to help people on the ground. And reconnaissance, which means taking a look at imagery for different purposes. They could be scientific, they could be security. And if it's short range in terms of where you're surveying, then once again, electric aviation has a great use case here. And of course, the one that I think we'll spend a lot more time talking about today is the air taxi environment, which is transporting people from points A to point B in urban, suburban, and even rural connectivity space, which is really important, because in order to be able to reduce the cost of this, we have to be able to have the platform be accessible to a range of different income levels, not just the extremely wealthy who might now currently take helicopters. So this has to be more affordable, more like the cost of a ground-based taxi ride. So what does this new passenger experience look like? Well, a lot of it is related to comfort, but then I think now also a lot of it will be related to human safety in the context of virus transmission. So you can see the interior of the cabin that we're working on in our aircraft. So spacious, comfortable, more like the interior of a, I guess you would call it like a limousine type of thing. So new passenger experience is really important in order for people to feel comfortable using these aircraft. This also does couple to a nice segment of society in the transportation space, which is mobility as a service, that has largely been related to ground-based ride-sharing applications. But the hope and the belief, and certainly the participation of Uber with Uber Elevate, is to include air transport, specifically aerial mobility, as part of that mobility as a service paradigm. And we do have operations in New York of Blade helicopters and Ubercopter using this mobility as a service platform. And what we can also see here in terms of the cloud space is that as we see an increase in traffic density in the air, we would need new solutions for traffic management and new solutions for collision avoidance and on-demand calling. And AI actually couples really nicely to that. I think we're going to have a discussion about that today as well, which is very germane. So there are challenges, of course, going forward to implement these new forms of air mobility, regardless of what the use case is. One of those, of course, is regulatory. Whenever you're building and designing a new aircraft, you have to design it under your country's regulatory space. And so for us, this would be the FAA in the United States and IASA in the European area, and the equivalents around the world. And so some of those regulations do need to be updated for these new types of platforms, because the aircraft types are a little bit different. And some of that's related to batteries, some of that's related to electric motors, and some of that is related to the airframe itself. So power generation is very important. Also power storage when it comes to batteries. There's some new regulatory space updates that are needed in that area, and any ground-based infrastructure would have to support the recharging of electric aircraft. So once again, you can see the coupling between power ecosystem as well as the infrastructure system. Public acceptance, I think, is a very important one. So I think people are concerned about noise levels. I live in Los Angeles myself, where helicopters are routinely used for aerial surveillance, and they are quite noisy. So a rotorcraft as an option for higher densities of travel isn't an option, which means that all the new technologies that are being worked on are worked on in minds with reducing the acoustic disturbance as a result. And that will help on the public acceptance front. And that's one of the many things that we have to do to make people feel more comfortable with this mode of travel. Infrastructure, also is key when we are going to insert these platforms into places that don't have existing helipads. But as I suggested earlier, existing infrastructure can work for some of the routes as new infrastructure is built. Airspace update will likely be required because there'll be corridor usage at low altitude at higher densities than has previously been done in the past, even with helicopters. And that's something that governments around the world are also looking at. And from a technology perspective, the push is definitely for autonomy for these platforms so that you can reduce the need to have pilots on board. There is a belief that there will be a tremendous growth in aviation overall, which means that there will be a pilot shortage coming up. So if you can have more aircraft which either require fewer pilots or no pilots at all, then obviously that would couple to the potential pilot shortage. And autonomy does also lend itself to enhanced safety. So one of the aspects that I think is very important is the infrastructure that goes behind green power to power green transport. And so there we need smart grid, there we need offshore wind, onshore wind, and solar to be able to ensure that the energy that we're putting into our batteries is coming from a green source to reduce the overall carbon footprint of the transportation system in general. So what comes next? I wanted to wrap up with my bread and butter, which is the space program and things that are funded by NASA and space programs around the world. I do believe the next type of aircraft will be a hydrogen-powered aircraft for shorter range travel, likely hydrogen fuel cells for longer range travel, possibly direct hydrogen power. We, of course, see hydrogen-powered flying vehicles in the context of the space program. Most launch vehicles do use liquid oxygen, liquid hydrogen as their propellant oxidizer combination. And in the commercial sector, we may see hypersonic flights within the next 5 years from companies like Blue Origin and companies like Virgin Galactic. And these are two of their test vehicles which have flown and have been demonstrated, but have not yet started their commercial passenger carrying operations. And of course, we do have vertical takeoff and landing aircraft, which are emission-free, already going to other worlds. The Mars 2020 rover has a helicopter on board, so which will be launching a little bit later this year. And then we do have another mission planned for landing on the surface of Titan, which will carry a multi-copter system. So that sums up my presentation, and I'd like to turn it back over to Nick, and I'll answer more questions in the Q&A. Thank you.
Thank you, Anita. That was really interesting. And I really want to focus on one of the things you mentioned. We have a question from the audience, which seems quite relevant now that you were discussing infrastructure. And the question is, isn't the cost of helicopter transportation in urban areas mainly due to the landing fees at heliports and airports? Now, that is certainly the case in the UK, but one of the things that we find is that actually the cost of landing fees at some of the more centralized locations is actually a function of some of the other things that we were discussing. So noise is one of the big issues, and landing fees are increased in order to decrease the number of movements at each of these heliports. Obviously, the status quo won't play very well with an urban air mobility solution. So how do you think that the landing fees and the economics around infrastructure will change in an urban air mobility environment?
Well, I think the United States is a little bit of a different model. So the landing fees are applied, depends upon the airport, depends upon the weight of your aircraft, for example. Most general aviation airports do not have landing fees in the United States, so you don't have to pay regardless. So my perspective as a pilot who also participates in the maintenance of our aircraft fleet is that most of our cost comes from maintenance in terms of why it's so expensive, and also the cost of fuel. So when you reduce the maintenance cost, when you reduce the fuel cost, you actually significantly reduce the per hour cost, up to an order of magnitude as compared to helicopter. So for the landing fee perspective, I think the noise one gets accommodated by the fact that you're designing to be 20 decibels lower than you would see for a typical rotorcraft. You would have to work obviously with your local government entity on this. And your other costs obviously come down because you've shifted over to this electric powertrain. You have a much simpler maintenance schedule. And this is something which is completely about the public acceptance one, because if the public views this as a direct replacement for a helicopter, we are stuck in that same place. And she's quite right in asking that question. But this is where we really have to work very closely as aircraft manufacturers, as regulators, as government entities to say how we're going to do this, why this is beneficial, why we solve these problems that the public is worried about, and then you can eliminate that particular landing fee concern as related to helicopters for these new platforms.
Okay. Yeah, no, I think that sounds much the same what we've been looking at as well. But no, thank you very much, Anita.
Thank you.
Our next speaker is Jenny Gardner, who is the head of strategy, combat systems, and C4I systems at Saab Technologies. Jenny's been working on radar technologies, electronic warfare, cybersecurity, aeronautics, and air traffic control at Saab, and is hoping to use some of these technologies to aid in some of the areas that we discussed earlier, that wider ecosystem to enable urban air mobility to actually scale beyond what we've seen with helicopters. Everyone, please welcome Jenny Gardner from Saab Technologies.
Well, thank you so much, Nick. And might I just take a second to say that I'm going to today talk about a particular piece of the system of what we might see as an urban air mobility kind of new transport system. And I'm going to talk about the air traffic management and air traffic control piece. So just think for a second that you are actually at the moment in a synthetic tower, because this is really what it's about. It's a video feed into a 360 view, and with that an augmented reality of different types and different type of feed-in, you manage air traffic. So that is really what I'm going to be talking about is. And but I do promise that during this session, I will not ask you to manage any air traffic. We'll do that next time. So my name is Jenny Gardner. I'm head of strategy for combat system and C4I solutions for Saab. C4I stands for command and control, communication, computers, and intelligence. And it's really about the enablers and drivers in the military nervous system, you could say. But it's also about system of systems. And that's really why I'm here today, to talk about the potential of that type of system. I will speak specifically about air traffic management and control, because two things. It's a really important piece of that type of system, but also I think we are doing some really interesting things that I hope you'll be enjoying if I cite you on. So just start to introduce Saab. So next page, please. So Saab is a company. It's a defense and security company. It's one of the, I would say, leading companies in that space. We have about 17,000 employees, and we work all over the world. We have quite a large portfolio of different products and services. And here on the screen, you see a couple of them. You see, for example, our fighter jet Gripen on the very left-hand side. And I just might also say that I have it behind me. And I also want to clarify that today I'm coming from Sweden, Stockholm, and we're not in a lockdown, so I'm in an office. It's a little bit unfair, but just to let you know that I'm kind of actually not needing to be in a lockdown. We see also just above the Gripen kind of aircraft, you see the digital tower, which I'm going to talk more about. But we also have products like the A-26 submarine, you see corvettes, air, land surveillance, and much more. Next page, please. That's our defense offering. We do also do quite a lot within the commercial sector, specifically with command and control systems. The digital tower that I'm going to talk about is one example, but we also have quite you could say experienced kind of commercial aviation portfolio. We fly aircraft, Saab 2000 and 340. We manufacture airframes for Boeing and Airbus. We do MRO and modifications and much more. Next page, please. So now I'd like to talk about the digital towers, and I will tell you the story how this came about, because it was really, you could say, innovation by necessity. So this happened in Sweden, and Sweden is a very long country. It's one of the also largest by area countries in Europe, or in the EU area. It's the third largest, but fairly sparsely populated, and specifically up in the north. So in the end of the 90s and the beginning of the 2000s, it got to be quite an issue that it got to be expensive to have these airports running, and the air traffic management and control cost was about 30 to 40% of the total cost of the airport. So you could say that the Swedish infrastructure was under threat when it comes to aviation. So we went together, Saab went together with LFV, which is the leading provider of air traffic management and control in Sweden, both for civil and military aviation. And 2006, we joined up with something called ESTADS, which is Saab's digital kind of solution kind of company that has been working with this type of challenge. And in 2014, we got the first contract to open a digital center in the northern of Sweden. The first ever in the world digital tower was put up in a northern city of Sweden called Örnsköldsvik in 2015. In 2017, the airport conservative type of tower was closed in Sundsvall, where the regional center was. In 2019, we now opened a new tower and a new airport in a place called Sälen, which is in the northwest of Sweden. And we now have 3 different airports running at the same digital tower. But that's just Sweden. Since then, we also worked quite a lot in Europe, you could say. We have in 2018, we opened the first digital tower together with Cranfield University at Cranfield in the UK. We're working with the London City Airport, and really kind of breaking news we also got from the Royal Air Force here in March in the UK, an opportunity to create a demonstrator together with them. We have in the Netherlands, we have kind of gotten a contract with the kind of Dutch air traffic control provider, a framework agreement for 20 years where we will work with them looking at the digital kind of service offering. So quite a lot of things have happened, you could say, between 2014 when we got the first assignment and today 2020. Next page, please. But that's really about the story. So now it's more to what is this digital tower and how does it work? Well, air traffic control has much been the same since the Second World War, they say. I'm not an air traffic controller myself, but there's high towers, various technical systems and binoculars. And what we're now doing is instead of having brick and mortar towers, we're putting up cameras and sensors at the airport. Everything that is recorded is then routed down to the center itself and projected on a 360 view. And what's so kind of interesting with this is that you get the image monitoring up on the screens, but you can combine that with radar display, navigation aids, and information about flight plans and weather conditions. And that is what we have today. But what we also can do is, of course, we work with video feed. So we can work with infrared cameras to see in the dark. We can work with augmented reality. We can plot runways. We can track drones, etc. So quite a lot of interesting applications. So this is really what is happening today. And I think it's also really important to understand that we're doing this in very close collaboration with the local transport agency. And it's all the security is in the same type of level as it is in a close collaboration to make sure it's the same kind of security level as it is in a physical digital tower. But that was really what I wanted to talk to you about, because that is really happening today. So it's not about the future, it's about today. But then what about the future? Because, you know, urban air mobility is quite a lot of, still, you know, a lot about the expectations of the future. And my personal view, and this is about the future, is that I think that we will digitally revolutionize the air traffic management and the air kind of flights in general. And I think we don't know about the timing, but we know that this is going to happen because of the technology increasing, the data flows, the economic globalizations, etc. And we know it's difficult now with the COVID-19, and the aviation industry is having quite a tough time, but the tangent really talks about that this is going to be part of the development. But what does that mean? Well, practically, I think the holy grail is really to provide the user with the right system or the right transport. So it's really going to be a lot about what the aviation industry also can come up with and match the challenges about the urban air mobility system and about sustainable flying for sure. But if you follow that pattern, we are going to get to, can go to the next slide. We can go in a certain amount of time, we can go to what you see on the screen right now, which is really about a digital kind of tower center. That would be the future. That's not happening now, that would be the future. And there you could see, you could combine all the different type of applications. You could manage different type of air traffic, military, civilian, drones, urban air mobility, eVTOLs, you know, whatever we'd would like to put into that. But of course, it takes a lot of maturity, a lot of development. And what we are doing right now is that we're working very closely with several universities from Singapore to Sweden to Cranfield and across the world to see what type of technologies can we feed into this type of development. So just to finish off a bit, I think it's all about a system. I think it's about trying to make sure that you service the users in the system. And I hope that air traffic, digital air traffic management can be a really important piece of that development. Thank you.
Brilliant. Thank you, Jenny, for that. I just had a very brief question before we move on to the next speaker. You mentioned that you're running 3 different airports from one of these single control towers now. Can you tell us a little bit about the scalability? Do you expect that there's going to be another ceiling where you're going to reach capacity? Is that something you've looked at?
Well, I think that's a very good question. And you could say there's a couple of things to address with that question. First of all, I think what we've been doing, and that has been really important in this process, is that it's been disruptive, but incremental at the same time. So I think because safety is such an important piece of the kind of solution, you could say, you just have to make sure that you make it incremental, but you take it one step at a time. I think a lot of these technologies that I'm talking about, looking at, how can the future look like, they will give you the answers of the scalability. For example, we're doing quite a lot of work on AI and, how you can actually, work with the type of information you get from the sensors. And as you go, I think it's too early to kind of give you a really good appreciation or an estimate of that.
Okay.
I think depending on how it develops, I think, there's quite a large potential.
So still early days with the potential to revolutionize the way we think about air traffic control.
Oh, absolutely. Very, very good. Well put.
Brilliant. Well, thank you very much, everyone. Jenny Gardner from Saab. Moving on to our next speaker, we have Earle Ahern. Will is the Chief of Staff for the commercial team at Lilium Aviation. Based in Germany, Lilium is building a high-speed electric aircraft that hopes to revolutionize the way that people travel. Lilium's been going for the last several years. I've actually been following with keen interest since at least 2016 with some of the subscale demonstrators. And recently there's been some very big news. Lilium has added another $35 million, I believe. Is dollars or euros? You'll have to tell us. Which I believe takes Lilium up to being the first UAM unicorn. Here to tell us a little bit more about Lilium is Will. Thank you very much.
Thank you very much, Nick. Very pleased to be here, and some fantastic and fascinating speeches so far from Anita more broadly about the general space, and Jenny particularly about one area of this technology and the implications it will have on air traffic control. As Nick mentioned, I'm actually coming at this not from the technical side or from the engineering, but actually on the commercialization and the rollout of this technology into what we will believe will be a service that fundamentally changes the way that we live and work. I lead our global launch efforts. That's everything from our strategy, commercial partnerships, and the establishment of our service. And what I'd love to do, I'll share a few words about the vision of Lilium today and the particular passenger use case that we're focusing on, as well as circling back to what Nick mentioned around some of the latest updates from our side as well. Lilium is an integrated technology company that aims to solve the problem of regional mobility. Our vision is a world where anyone can fly anywhere, anytime. And that means we've developed not just an aircraft that we intend to sell or let other people operate, but actually want to integrate this into a service that we'll offer direct to people all around the world. As you'll know now, regional travel is pretty painful. If you think wherever you are right now, how you get to the next nearest city, it's probably using 3 different options, either via car, bus, or conventional rail, all of which is pretty slow. You can use high-speed rail where it exists, but this is, of course, incredibly costly to build and one-dimensional. You can only go back and forth between a couple of points. And then occasionally you're able to do this by plane. Usually over a certain distance threshold, rarely below 200 miles, but this is of course a disaster for the environment. However, when our founders set out to solve this problem of regional mobility, they realized the best way is to use an aircraft. Because you don't need that connecting infrastructure, you don't need to invest in the ground-based road and rail solutions that otherwise are used. So we decided to build an electric aircraft. And we've talked a lot about sort of the sustainability goals, or Anita has talked about the sustainability goals the governments are putting forward. It's of course necessary for any new regional mobility service to be fully CO2 neutral. We also wanted to make it possible for you to go from downtown in one city to downtown in another. So of course we had to use a vertical takeoff and landing type of technology. That means you can land and take off very close to where you live or you work, and then travel direct to the downtown central hub of another city. And we, of course, want to make this in the future accessible and affordable to everyone. I mentioned our vision of really democratizing air travel. So we plan to deploy these aircraft in our own service, working with partners to build infrastructure and roll this out around the world, but of course, running this as much as possible ourselves. So how are we going to do this? We're starting with a shuttle service that will connect city to city, potentially London to Manchester, this type of network that you'll be able to then travel at high speed without the connecting infrastructure. We'll then move to a more on-demand service that will connect to lots of smaller communities, in a way enabling you to go from your small village where you might live in the countryside into the city centre, something which will be radically different and hopefully will reflect the changes in the ways of working that we're seeing happening all around the world today. And over time, we expect that autonomy will become possible, enabling us to reduce the price of this service to that of car ownership or even sort of train travel today. This will have a huge impact on how we live and work. It can turn an entire region like Switzerland into one metropolitan area that's as easy to travel within as London is today. If you take what we call your radius of life and imagine where you are right now, if that's and how far you can go within 1 hour. If you're within a city, typically you're not going to be able to travel very much distance within 1 hour. However, with Lilium, you could go at least 5 times further. And that increases your radius of life by 5 times. So your area of life increases by 25 times. That's 25 times more places that you could connect to within 1 hour. This is the vision of Lilium, and Nick mentioned we've been incredibly fortunate over the last couple of months, despite the global challenges, to have this validated by a number of investors. We've raised, just in the last few months, over $275 million, 35 million of which was announced yesterday from one of the leading investors actually in the technology space, one of Tesla's largest shareholders, Baillie Gifford. And despite Corona and the challenges that we all face, we continue to press forward on this mission with this strong backing that we've seen. We're focused on really developing our aircraft against the certification standards that the regulators are setting, proving that we can meet the high standards required for the commercial aviation, equally preparing this aircraft for mass production. Setting up our factory, we have 10,000 square meters of space near Munich today, and establishing our first production lines to bring this aircraft to the market. In parallel to this, the area of the business which I'm focused on is our market development, finding partners to build the infrastructure, finding governments and regions that are interested in seeing this service deployed and investing in a new and green solution that will solve their problems of regional infrastructure and regional transportation. We're very, very lucky with the support that we've received. I'm happy that you mentioned it, Nick, and we're incredibly grateful that actually we continue to be able to execute on this as we weather the storm going forward. Still a few years from commercial launch, so although it's an exciting mission, there's a lot still to do. We intend to be in multiple cities around the world by 2025. So for us, the focus really remains on these 3 streams: engineering our series aircraft, building up our industrialization capacity, and of course, preparing our first launch markets. And despite all of the challenges that we face today, I'm amazed that we're able to do now a conference virtually. We don't intend to slow down anytime soon. Thank you.
Thank you, Will. That's really interesting. And just to pick up on something quickly before we move on, you mentioned that you're going to be, or aiming to be, in multiple cities by 2025. Can you tell us a little bit about some of the candidates or how you're looking and searching for candidate cities to launch the Lilium service in?
Absolutely. I think, as I mentioned, this is a regional service. So we're really looking for routes where there's a clear value proposition, a clear time saving to be gained. If there's 2 cities connected with a high-speed rail route already, probably it's not the best candidate for us. But there's really no region in the world where you can't deploy this, because even where you have a high-speed connection to date, it's just going back and forth between 2 points. We're very, very active really across the world now. It's, we believe, a global solution, one that can be deployed in Europe and the US. It can be deployed across, of course, the Asian and emerging markets. There we have huge mega cities that you're able actually to connect to their entire surrounding region and also potentially within them. And equally, it serves a potential purpose for the developing world where you can frog leap the entire introduction of connecting ground infrastructure. Take Mombasa to Nairobi in Kenya. The road is dreadful. Most people fly to date, but it's expensive and it's polluting. So you could replace this city-to-city connection with an electric service.
Brilliant. Thank you so much, Will. Really appreciate it. Our last speaker is Michael Cervenka, I hope I'm pronouncing that correctly, who is with more than 20 years of experience in the aerospace sector. Michael has recently joined Vertical Aerospace to become the CEO of the UK's leading eVTOL manufacturer. Vertical Aerospace is a relatively young company, but has a philosophy of learning by building, and is currently working on their third full-scale prototype. Here to tell us a little bit more about Vertical Aerospace's plans for the future is Michael. Thank you very much.
Hello, thank you very much. I guess one of the plus sides to living in a rural area in a COVID environment is the beautiful countryside. One of the downsides is the internet connection, so it's been playing up, but fingers crossed we'll get through this. Yeah, I guess I joined Vertical 12 months ago. It's been an incredible journey. Vertical actually was founded in 2016, and some of the reasons for founding Vertical chime with things that we've heard already. We were founded by Stephen Fitzpatrick, who's a very successful businessman in the UK. He founded OVO Energy, very much on a mission around sustainable energy, and OVO is now the second biggest energy provider in the UK. So climate change and you know, the fact we all want to fly, but how do we do that in a sustainable manner is very much a founding principle. And then the other factor that has already been touched on is this mega trend around urbanization and the opportunities that presents with 2.5 billion people more living in cities by 2050, ground infrastructure, of course, unable to keep up. I think a couple of things that are perhaps different about Vertical, though, compared to a number of the other companies. Firstly, from the outset, we've had a really strong view of partnerships. So we're trying to develop a brand new aircraft in a new ecosystem where the regulations aren't all defined, and grow our own company. And since 2016, since we were founded, we've now grown to about 100 people. But actually, for me, I think the real opportunity in aviation is to combine that single-minded focus and agility and pace of a startup with the deep expertise and pedigree of big aviation and other companies. So in our case, as a good example, we're the only eVTOL company globally to have signed up Honeywell to deliver us a flight control system. By doing so, we can access Honeywell's amazing technologies. So the same technologies that control the F-35 Joint Strike Fighter, the world's only supersonic VTOL aircraft, we're bringing that to bear in a really pioneering advanced vehicle. And we'll have many more of those kind of exciting partnerships that we'll talk about and unveil in due course. Another thing that's perhaps unusual about our company as a founding vision was how do we combine the rigor and safety culture and knowledge and certification expertise of aerospace with the pace and agility and different mindset and different technologies from Formula One. So strategically, we're very deliberately located with our main base in Bristol. Bristol in the southwest of England is one of really 3 aircraft hubs globally. There are 270 aerospace companies in the vicinity, ranging from the Rolls-Royces, Airbuses, Leonardos, right down to lots of small outfits. So that gives us a fantastic access to a whole ecosystem of talent and capabilities. But then last year, very excitingly, we acquired a Formula One consultancy led by Mike Gascoigne. For those of you who followed Formula One, Mike's a veteran. Through his career, he's led many Formula One teams, ranging from Renault, Tyrrell, Toyota, Benetton, Caterham, has delivered 27 Formula One cars. But then I think a few years ago decided to set up a consultancy, and they bring a huge level of expertise in things like lightweight composite structures, advanced engineering, rapid prototyping, and so on. So these vehicles are doable, but they're really challenging. I think it's been touched on, having a sustainable vehicle is a founding objective. It's key to make this successful, but batteries, of course, are limited. So bringing those pioneering technologies, that real focus on weight and different approaches, I think is really key. As Nick mentioned in the introduction, we are one of, in fact, only 7 companies globally to have flown 2 full-scale prototypes, Lilium being another. And I think, you know, the learning that you get from doing that is really key. So we've got a really exciting future ahead, and looking forward to the discussions that we're going to have in the panel. Thanks very much.
Brilliant. Thank you for that, Michael. Before I let you go and before we wrap up, I just want to talk a little bit about the avionics you mentioned with Honeywell. Sounds like that's obviously going to be a core part of the technologies. Can you tell us a little bit about how the technologies are being developed right now that may enable autonomy later on down the line? Is that an option that you're looking at?
So very much down the line, I think one of the reasons we chose Honeywell was we actually did a global search for all the different providers. The flight control systems, if you like, are the brains of the aircraft. So these vehicles have got many different rotors. In a conventional mode, the wing we're developing now will have conventional flight surfaces. But we really want to make the vehicle incredibly simple to fly. So the first starting point is having a flight control system that enables that. So literally, as the same technology you'd see in an F-35, it's something called the Unified Flight Control System. If you want to go up, down, left, right, faster, slower, it's really simple for the pilot to basically tell a series of computers how to do that, and the computers take care of all of that. It's got full envelope protection. You know, the vehicle can cater for different types of failure modes. So really the starting point is they're really easy to fly. And as a non-pilot, having flown simulators on helicopters, which are incredibly hard, and then flown in Honeywell in Phoenix simulators of these kind of vehicles, that's a real step forward. I think the wider avionics suite then is, well, how do you make all the other aspects of aviating really simple? So how do you do all of the optimized pre-flight checks, really communicate to the pilot with really strong human factors, so you simplify their workload? And that's the starting point. So our vision has always been to have initially a piloted vehicle. For us, we therefore want something that can carry several passengers to be commercially viable. Having that, I think that's vital in terms of public acceptance and regulatory acceptance to have a pilot on board. But pilots, we know, will be a bottleneck. So how do we have a vehicle that is incredibly simple to fly? Yes, we'll have highly trained pilots to start with, but over time we can bring down that training barrier and open up greater markets. And then a key part for us around Honeywell was the avionics suite, and the flight controls is very much an open architecture. Honeywell's got a whole suite of technologies like really lightweight, small, compact radars for collision avoidance, sort of broader computer vision technologies, etc. But the ability to bring in other partners into that. I don't think there's one company that's going to have this magic silver bullet that will solve all of the autonomy issues. So having something that's upgradable and enables us to leverage a much broader technology suite means, for me, it's a journey from increasing automation towards autonomy. So how do we simplify and automate increasing bits of the flight envelope? The pilot really is there just to avoid things, to take the kind of decisions, reactive decisions that humans are doing, but over time increasingly automate and eventually towards a vision of autonomy.
Okay, so all about building capacity to increase autonomy, reduce pilot workload as you go forward into the future.
Exactly.
Brilliant. All right. Well, thank you, Michael. And before we wrap up, I'd like to thank all of our speakers, Anita, Jenny, Will, and Michael, for their time today. I'm going to hand over back to Sue, who's going to tell us a little bit about the Q&A, but please join us. It'll be great to have some more discussion with the audience.
Want access to more CogX videos? Subscribe now for free at cogx.co.